Today I'm doing sliding window maxima. Hello everyone, welcome back to another sliding window video. But before that, I need to do this again. Find all anagrams in a string. I did this in the first video of the sliding window, and I wasn't able to get it. But now I know what to do. So yeah, let's try it again. Okay, I'm just gonna quickly type out the template. Well, we always need an end set to 0, and we always need a begin. That are our two important pointers, and after that we need a hash map to mutable map of character and integer. Okay, after that, yeah, I also need to keep first. Okay, let's first fill this map. So for each character in my S, for each character in my P, because we are finding this substring in the main string. So for each character of the substring, map.get is map.get or default it 0 and +1. Yeah, so that's our frequency map. I need one more variable, which is count, which I will use to keep track of the number of characters we have seen and when it's time to move my second pointer. So I'm gonna set it to my map's size, and so while and is smaller than my main string's length, I'm gonna check. Okay, wait, what should I check? End character is s at and if map dot contains key, if key is present in my map, then I'm going to is equal to map.get or default map.get is a nullable type, so I don't want that. It's like this method is right. End character or 0 minus 1, decreasing the frequency. Now I'm checking, okay, is if the frequencies become 0, then that means it's time to decrease my count. Okay, and when my count becomes 0, that means that I have that my end has got to a point that I have found a substring in which all these characters exist. I have found a window So when it's 0, right, because we need to return the starting index, I will check. Because it's a substring, so that means all the characters are next to each other. But what can happen is that my window can get really big. For example, there is a B here and A, and there is one more B and A B C. So here in this case, my window's size is 5, 0, 1, 2, 3, 4, starting from fourth index. But these first two characters are really just they are not important. They're duplicates. So the right starting index of my window is 6, which starts from this B. Okay, so I can say that if my window size, my end minus begin, is equal to the size of my substring that I'm looking for, and that should be what? That should be map.size. If this is the case, then okay, I found the starting index I'm looking for. So let's have a result array here. Mutable, mutable list of int. When the window size is equal to the size of the substring, then add this begin. Yeah, begin. And I think the rest of the code is just let's copy this. Just copy the entire thing. For begin character is s at begin, and now this is important. Should I make it yeah, let's first try. If the frequency becomes greater than 1, then that means if it becomes 1, okay, if it becomes 1, then increase my count. Here I'm checking for the size. Okay, return at the end, return my result list. And I think that should work. Let me just go through this one more time. Begin and end, and then this, and then count is set to the map size. Could I have also and character? Oh, it should be +1. 0 minus minus. Yeah, I need to move my pointers as well. And plus plus. Line number 47. Not integer, int. Size. Cannot be invoked as a function. Okay, size is a property. 26, 25, 26, and 40. Where else am I calling size? Okay. Should have worked. Should have worked. Okay, what's happening? What's happening? My hand is. What's happening? What's my? Am I creating wrong map? What's map? No, map is fine. Oh, just -1. And here I need to increase the frequency. Okay. 6. Why not 0? Why not 0? Let me look at my window size. So 2, 0, 1, 2. All right. I got it. I need to. Okay. Now, I knew something like this is gonna happen because it's always a problem. It's always a problem when we have duplicates in our inputs. I'm pretty sure it has something to do. Okay, AA. My window is 0. Right. Right. Let me see. Let me see the logs. Z. Oh, what is the size of my map? Size of my map. I got it, because size of the map is only 1. But even though the frequency is 2, size is only 1. So maybe the better way to do this is to use the size of P, but there can be duplicates there. Let's try. P size. P size. What? Length. Should I use length? Okay. Yep. Okay. That was easy. Relatively easy problem. 23. Okay. The main problem for today. Sliding window maximum. And as we learned in the template, I think if it's here, it's not here. Okay, so well, according to the template, when we are looking for the minimum, we should for logic for the minimum should go in the inner loop, and the logic for the maximum should go in the after the inner loop. So let's see if that works. We are given an array of integers num. There is a sliding window of size k, which is moving from very left of the array to the very right. Very left of the array to the very right. You can only see the k numbers in the. I'm not sure if this problem would follow that template or if it's another kind of sliding window problem. If you can only see k numbers in the window. Okay, we have a window of size k. We can only see k numbers in the window. Each time the sliding window moves right by one position. Right. K. Okay, the size of the window is given in this problem. K means first three elements, first three numbers, and you can only see the k number of. Okay. Return the max sliding window. Max sliding window. Like the window which has what max, like the window which has the maximum sum. I think yeah, that's right. So sum of this window is 3. 1 and 1 cancel each other. And the size of this window is also 3. Size of this window is 5. Size of this window is 5. Sum of this window is 6, and we have 7. That is which is the maximum. Right. Maximum 3, 3, Okay. All right. Return the size of the sum of a window. I got it. How about using a data structure such as DQ, double-ended Q, double-ended Q? Q, priority Q, monotonic Q. I've heard about mirroring stack, not one monotonic Q. Can my template be applied on this problem? We are not actually looking for a window. Are we? So if I were to choose my begin it's set and is set at k, yes, and because it's 0 index, this is the size of my window. And while my end is smaller than my length, and in this I'll be updating end and begin at the same time. Right. So I think it'd be very, very inefficient to search a look to calculate the sum of the window each time the window moves. So I think the better way would be to have the sum pre-calculated for the first window and sum so for I in I until k, sum of this window plus nums y. Wall result is mutable zero, 1, 2, 3, 4, 5. 3, 4, 5, 6, 7, 8. Array int array of size nums length minus k. And let's set this to sum of this window. And now I can say for sum of this window is equal to num plus equal to num begin num end. Minus num begin. Index 0 index 3. Alright, and at the end I will just increase my index. I'll return this result. I don't know, this all this looks too simple, and it should not. It's a hard problem. Some of this window, and here we're just moving the window. Okay, let's see. Length 36. Nums size. Hmm. 46. 6. Twelve. Three. That's right. And then 1. That's not right. Hang on. We're looking for the max element. Oh god, I did not read it right. 4 minus 1 is 3, and then 3 minus 4 is -1. Okay. So we kept the previous element, the previous sum, and in this one, fine. -4. Or are we looking for the max? The queue size not need to the same as the window size. remove redundant elements and queue should store only elements that need to be considered. I get it that I need to use a queue. New intersection. Brief. Maximum window substring. Maximum. Okay, I know I was supposed to use some kind of queue for this problem, and I get it why. If the size of the window is really huge, long, then and we need a max element in each window of each window. Not the sum. And we could also loop inside the window, but that's like, yeah, that's very inefficient. Because we'll be looping each time window moves, each time in this array. Okay. How would how can I do this without using queue, without using a queue, and in a way that it's slightly better than looping each time. So I'm thinking of that. Well, I can pre-calculate my max. Max is 0. Max is equal to max of max. So I have a max. And I can check if the number that just got out of window, so I can see if the number that just left the window, the nums dot begin, if that number is equal to max, no, because the middle number can. Okay, first of all, we have numbers that are at the at each end of the window. So here 3 is the max, and in But can we do this? Can we do this? Can we do this? Max is equal to max of max and the number, the new number, max new number, and three is the max. Here 3 is the max. So this 3 left the window. This 3 left the window, and this 5 entered the window, which is a coin. So we set new well, this will not work for bigger pieces. It should not. Yeah. K is 1. Expected 1 1. Expected made. So the window size is if my number was okay, I think it's time to look at the solution or just get some idea of what I with DQ explanation, brute force to mono DQ. Nested loop goes through window and the complexity. We can either reduce, balance, binary research. is not empty, q dot p is smaller than, okay, we had indexes in the queue. That means if the index at the top of the queue is smaller than, and there is some kind of window size, I minus k. What's k? K, yeah. Okay, the window size. If the index at the top queue is smaller, then my window size pole. Okay, this is the same syntax. The same syntax just seems very similar to monotonic stack, where we peak last. Peak last. This is basically a stack. Peak last. I think peak last is for, let's just check. Java array dq. Peak first. Retrieves but does not remove the first element of this key. The head of the queue represented by this. The first element of this queue. Remove smaller numbers in k range as they are useless. It's is not empty. It's not empty. TQ first. So then remove I. Okay. I think this is very close to the substring template. Here we're checking, okay, if the current window is equal to k, if the result dot add max queue's first element, if that element is equal to nums I. What's I? Does I represent the okay, so I means the starting point. If this element, this number is equal to the first number in my substring in my window, then we remove that number. Poll first. Okay. Okay, last. Okay. Excuse not empty. X is greater than. Mm, I'm maintaining a decreasing DQ. If the new number is bigger than elements at the back, element at the back, those smaller elements can never be maximum. If the element leaving the window is maximum, it will be at the front. This works because okay, got some idea of how the solution is working. Yeah, that's it for today. Bye bye. Oh no, yeah, bye.